Hello, everyone. So today we're going to be talking a little bit more about how to make and use figures. So figures are going to show up pretty much throughout the paper, but uh, everywhere going from the introduction down all the way down to the conclusions. But they're typically going to be showing up in our results and discussion. But one of the important things to remember is why we're using figures. So the most important part of why we use figures and not just write everything in the text is that there's some information that is just isn't well suited to being described in words. So if you can describe something in the text, please go ahead and try and do so. But if it's going to be a lot more convenient or at least more simple to use a figure, go ahead and use that too. That's one of the true tricks of writing a paper is knowing when something will be better suited for a figure and when something's a little bit better suited for the main text. Now, one of the things that uh, really should be noted is that one of the major features of why we're making use of figures is simply because there's often just too much data to be coherently communicated in paragraph form. We don't want our paragraphs to turn into just big long lists. So in order to do this, we often consolidate it, especially down into tables, or if it's just inherently visual and it's hard to describe what a structure looks like, make use of a figure, because sometimes a picture's worth 1,000 words. But one of the big things that a lot of people forget about is that our figures and our text should be able to stand completely independent from each other. Now, what this really means is that I should be able to look at a paper and read the text and never look at the figures, or look at the figures and never read the text and at least have a good idea of what's going on. In reality, I'm going to have a much better idea if I look at both of them together, but each one should be able to be understood on its own. And this can often be a little bit tricky in practice. So let's go ahead and talk about, first of all, how I should try and connect my figures and text together. So one of the things that's important to note is even when I'm using a figure, it should always be referenced in the main text. That way, if I'm reading the main text along and I want more information, I know when I should go to a figure and exactly which figure I should go to. So for exa- um, so for example, the way we often approach it is we'll go ahead and start off a sentence describing what I'm talking about, and then we'll essentially point the reader to which figures this corresponds to. So I'm, say, talking about the impurities in my block copolymers. Well, I'm going to give you the full list of those impurities in figures 1 and 2. But you'll notice that I always start off with the text. You should uh, you should always avoid starting a sentence or a paragraph with a figure label. Always focus on the narrative when you're working in the text, and then essentially use the at the very end of the sentence point the reader to where they should go to. And you can do this also when, say, referencing spectra, or when essentially pointing the reader towards plots or relationships. So again, you'll start with a sentence of saying what the information is and what it's looking at, and then you'll go to where it's located. And this can either be referenced directly in the text with the classic as shown in, or just referencing the figure directly, or having a complete independent sentence where you then at the very end say what figure you can find this information in. Now, what you should always avoid is essentially simply pointing the reader. So again, avoid starting off with referencing the figure and saying that, oh yeah, these figures show blah blah blah. You should always start with continuing your narrative and what information you're talking about, and then incidentally, you want that information, go to this figure. So again, this is how we should treat our figures in the text. But what about our figures themselves? So our figures themselves are going to have a lot of variety. But one of the important things is that, say, I have a full um, full example figure that gives me a lot of information about, say, in this case, a catalytic cycle. Well, in order to know what this figure is telling me, every figure should have a caption right below that describes in detail what can be found in the figure. So again, um, because our figures and our text should be able to stand independently, I should have essentially enough information in this caption that I can decipher what this figure is telling me with never having looked at the text, as demonstrated by me taking a figure completely outside of a paper. And I can still say, all right, we're showing the absorption of 4 photons of light by, hey, look, I know exactly what catalytic system I'm looking at. This corresponds to photosystem 2. Look at it, we're doing 4 photon absorptions. I can point exactly where they're at. Oh, and we're looking at splitting of 2 water molecules to O2. I know what the catalytic cycle is. And S states represent various oxidation numbers. So unoxidized, 1, 2, 3, 4. I got all of this information and I don't even know what the paper is. By the way, it is a wonderful paper about the artificial leaf. If you're interested in artificial photosynthesis, please follow the link. But one of the important things that's worth noting is that sometimes somebody generated a better figure. So if you go ahead and find someone who generates a figure that you really like, but you maybe need to adapt it for your own purposes, go ahead and make sure you cite exactly who you borrowed the figure from. If you're pulling it directly, then go ahead and say, then you can more deliberately say that it is essentially located or from the other reference. Though usually you have to do some sort of adaptations to make it relevant to what you're doing. But if you're even inspired by someone else's figure, make sure to cite them. It's only polite. Now, figures do include a great deal of information, like, say, general pictures or catalytic cycles. But one of the classic forms of a figure is the good old graph. And we're going to be making use of a lot of graphs in this class, starting with our good old-fashioned linear correlation. So whenever we're constructing a graph and figure, we always need to make sure to be a little bit aware of some constraints that you may have not realized when in previous chemistry classes. First and foremost, if you have a set of graphs, there is going to be no title for the graphs. All of the information is essentially going to be provided in the caption, as well as the axis labels. Now, one of the things that is worth noting is that especially if you're dealing with multiple data sets, which is often a good way to approach the system, you should make sure to include the legend either in the graph itself, or occasionally, if that's cumbersome or there isn't enough room, you can occasionally give the information of any information that would typically be in a legend in the figure caption to help distinguish which data points or which lines correspond to which set. Now, one of the biggest things is that a lot of what we're going to be doing is trying to generate fits of data, whether it's a linear fit or a quadratic fit or an exponential fit or something a little bit more advanced. When you're doing this, you should always give the equation of best fit in your figure caption. Now, one of the other things that's really important is to make sure that you provide the errors in your slopes and intercepts, especially if it's a linear fit. If you do not do this, you will lose points. Also, something else that's very important is always use the variables of the fit itself. In this case, I'm plotting the log of my equilibrium constant versus a set of external variables. Now, one of the things to make note of is if you go ahead and use X, Y, and Z, you will lose points. Make sure to use your variables. It's very important to help make sure that, that any sort of equations you use are as readily digestible for the reader as possible. Now, we also have other types of figures, including very prevalent in chemistry, chemical structures. So a lot of times we're going to be dealing with multiple chemical species, and some of these can actually be quite complex, where just providing a simple name might not give the reader enough information. So if you're dealing with a complex and not a kind of standard chemical species, I highly encourage you to say, provide the actual chemical structure to make it easier for the reader to follow. Now, especially when you have, say, in this case, complex organometallic species, well, it turns out that these usually have quite long names. So using a figure might be a good way to essentially provide a short naming scheme, because it's going to be a lot easier if I'm, say, referring to this complex to instead give just A or E instead of the full, actually quite long name. So again, making use of figures to simplify referencing chemical structures and chemical species can be a great opportunity that really shouldn't be missed. However, one of the important things to make note of is that, especially in chemistry, we often care about reactions. So if I have multiple chemical structures that are going to make a reaction pathway, occasionally this is done as a figure as seen previously, but especially if I'm going with full mechanistic details and conditions of reactions, we're typically going to put this forward as a scheme. And again, schemes typically do not have figure captions. Instead, they have a rather simple title. So again, a slight difference in between a figure and a scheme that is worth noting. And again, the title should, as briefly as possible, communicate exactly what I'm looking at and any relevant context. So in this case, it's focusing on the synthesis of a simple species. Occasionally, you may provide additional information such as conditions or relevant precursors or conditions. But again, should try and succinctly summarize what the scheme is examining, which often focuses uh, on the identity of the product and the general type of mechanism, whether it's a synthesis or a degradation. Now, again, because we're dealing with a lot of numbers in PChem, one of our real benchmark sort of figures we're going to be dealing with is going to be the tables. So we're often going to be trying to convey drastically large amounts of information in our work. So in order to do this, we're going to try and summarize it as succinctly as possible in a table. So again, there's going to be a lot of flexibility in how you format the table in order to try and convey as much information as possible. But one of the things that's very common is that, again, we aren't using a figure caption so much in a table as, again, a title. So again, the title should be trying to succinctly, within a sentence or two, summarize what information my table is conveying. So again, we're going to focus in on what we're studying and any important context, such as any important conditions, such as here, looking at photovoltaic efficiencies under a single sun worth of illumination. So again, this is kind of like referencing the pH of the system that you're studying. Now, one of the important things to make note of is that for a lot of figures, a simple title won't convey enough information to, say, describe what's present in each of my columns, especially when I may be dealing with complex units and I may need to try and work it within a small space. In that case, we actually can make use of figure captions below the table to provide additional information. And it's worth noting that these figure captions can get, well, quite long and lengthy. So for example, in this case, we have different pKa and rate constant information provided in 4 different columns. And each of these columns has a caption that's referenced below that gives me the exact information of, say, what conditions each of these steps were conducted under. Because again, I need to be able to try and make my figures stand separately from my text, as well as in this particular experiment, multiple conditions were used, so it's worth providing as much and as precise as information as possible to clarify exactly what was being studied. So hopefully this gives you a good sample of some of the good ways to set up figures, tables, uh, and schemes in a typical paper. So next time, we're going to dive a little bit more in detail of how to write a good results section. Till then, take care.